Hi, everyone. We're the Co-Locators group. We were all working in the auditorium, so we took a picture with the screen. Anyway, so I'm Molly.
Sophie.
Matt.
Micah.
Yeray.
Jazlyn.
Shikhar. Pedro.
And so our objectives for this Oceanhackweek was to query a large list of AirDAP servers, and there's actually a compiled list on GitHub by an Irish Marine Institute, and it's called Awesome AirDAP, and we've also added, we actually did their pull request thing and added more servers to it. So basically we wanted to have a map, choose a region in the ocean, choose a time frame, and just try and get everything, but there was way too much data, so then we added on a standard name parameter that you could like sort of click through. And then we wanted to display it and try and be able to interact with it, and I'd say we were pretty successful.
Yeah. So what we did was exactly what we wanted to do, which is search the different AirDAP servers for a specific region and time period. We created a Conda environment for our package with all of the modules, and we, which will be just demoed later, we got interactive maps, so you can choose the region that you want in the ocean, and it will show you the data that is there. We put all of it on GitHub, and we tried to use as many as possible the tools that we learned about this week.
Okay, but we had some problems. At the beginning, it was more like a quality control of the AirDAP links. We had our most common error was HTTP errors. So we got all the ones you want from 400, 500, 600. We saw all of them, I think. And then we had so much data. I mean, yeah, we were maybe ambitious that there was a lot of data, so we had to select. They will show you later also. And then also, like sometimes you selected, we selected a region and maybe it was due to the metadata, but then there was nothing inside of it, so we had to deal with that too. And then even though we specified only the table.dap data set, sometimes we had the gridded ones appear too, so we had to refilter this. And then, yeah, when we, after doing all of this, for the moment, we only load a maximum of 10 data sets randomly from once we've assembled all the different AirDAP servers. So yeah, we don't need to overload the AirDAP servers so we don't get any angry people. And we'll show you now.
All right, so now wish me luck. All the pressure's on. Okay, so I don't know. Do you guys? Who wants to walk through the code while I'm doing it? Do you want to explain what's going on while we're running through it?
So I'll give it a shot. Okay, yeah. Start hitting enter. So we made a module, made a Python module to encapsulate a lot of this stuff. This is the input to the interface. So Matt's gonna draw a box. Hopefully, pick a good one. Don't get too ambitious.
Yeah.
So this is going to actually go out and query all of the AirDAP servers that are known to anyone who deals with AirDAP. And he's entering a date filter now, so that's a lot.
You think that's gonna be too much?
Yeah,
we're gonna break it.
2019.
All right.
2019. So we're looking for any AirDAP data sets that intersect with that time interval in that geographic area, and that have seawater salinity data. And this is just a random set of standard names that we chose to test with, basically. So now you run the query, and we talk about something interesting.
Yeah. So what it's doing now is it's hitting each of those URLs. And the really cool part about AirDAP is you can do kind of a global search on each server to say, give me anything that's within these bounds and within this time frame. And so what it's doing is it's going and looking at each server and say, giving us back a list of the data sets that fall within that time frame. And so you'll see that some of these are giving us like 400 or 500 errors, and that means that that data, that AirDAP server actually doesn't have data within our requirements. Are we good? Yeah, so at the end, so see, now we did the search and we found 1,255 data sets on all those servers that matched with our criteria. Each one of those data sets could have 1 million latitude and longitude points, so we got to do some filtering so we're not killing our server or killing our plotting function. And so what this is doing is going through and saying, hey, I only want 10 data sets. So it hits the server and the data set and just gives us whatever meets within our criteria. So it's getting us just the data for that time period we selected and for that bounding box and for that keyword that we looked for. And it takes a while.
Because this is actually like requesting the data itself,
right.
Not just looking through the metadata, which is what the first search was. Now we're actually being like, hey, send us this.
So we cross our fingers and
there should be a plot.
So we didn't quite get to the point of figuring out how the interface should work at this point, but like directions that this could go is we just wanted to basically for this week like visualize the data on a map. So get a set of points and to be able to see what we actually found from this sub-selected query. We could take it from here to maybe like actually do like a clip and zip and ship or whatever. So you might be able to see the list of data sets and pick a few that you want to download, but that's going to happen some other time.
And this is where we could use cloud resources to kind of go out and do all those queries and bring back all that data a lot quicker than running it on my laptop. But it's working. It hasn't failed yet.
Anyone else have something?
Yeah, there we go. Yeah, we can do questions while we're, yeah, there we go. So we got some data. It might be a lot. So this stuff might not work very well. Because that took a lot longer than it should have. So I think we got a lot of data.
We didn't get the. Yeah, so you never quite know what you're going to get.
Yeah, so it froze. So, but you get the idea. So you get the plot, and then there'll be a hover over, and what that hover over will tell you is the data set ID, and then the hope is, yeah, there you go. The hope is that you'd be able to click on the different data sets, and then that would give you the response. So you could go out and actually get the data and get whatever you're actually interested in.
And the plot also has different colors for different data sets. So if you have, like if it is a glider track, and you can see all of those maybe yellow sort of thing, or if it's a buoy, it's orange. So that's a way to distinguish what you're looking at before you hover over and click the actual data URL. Yeah.
That was it?
We
have more in the slides. I forgot about that. Let me get out of here. Where did it go? Oh, did I kill the browser? All right. I think we talked about all this.
Should we sing along?
Should I play it?
Yeah. So we'll demonstrate first, and then you guys can sing along after. Please turn it up. Okay. 44 servers and more to go. Air depth data storage. Open as it's old. And all you do is give it lots of date. There's that Oceanhackweek here to co-locate.
More to go, early data storage, and packs to go. Code and hacking, the box and date. Oceanhackweek, hard to wait. There we go. Yeah.
Any more questions?
Any other questions? And we used the ERDAP Pi module. Basically, we abused it to beyond capability. Yep. No, that's the next step, because there are same data sets on different servers. So, and you found that out, yeah. So there's definitely a filtering capability that needs to go on. This is kind of a proof of concept if you could get stuff.
And also there are some like global data sets that it fits within our parameters, or like our parameters fit within that data set, but then if there isn't actually anything there, sometimes there's just empty data.
Yeah. When there's wrong metadata. So write good metadata. It helps. Do you have a question?
So the idea of the plotting too is to have the light to the
Yeah. Yeah. Then maybe start adding in geophysical variables as you get down. It's just a little much at the beginning because you get so much data.
And also you can have the direction, the URL, so you can download directly the data.
We realized that we had to add more filtering because we were getting so much stuff.
Yeah, like 4 million points.
Yeah, which makes sense. But
One last thing is we started, we were trying to put together like a really cool dashboard like demo, but we started looking into tools like Panel and Plotly, Voila, to put it together into like a dashboard, but we found some incompatibilities there between the mapping libraries, like the charting input and the visualization and HV plot. So, and I think that's going to be resolved, but we couldn't quite get this to work, unfortunately.
Yeah.
So, okay, first question. It's not actually a question. Sorry, I'm going to break the rules. All these issues that you're finding, try to file issues Web3. A successful hackweek means we had PRs to third-party repositories, we did it, we had a package, we had prototype of packages, we had machine learning. So the next step is involve you to open issue. So open an issue about that. Say, oh, we tried to do this, it didn't work. Now, a few suggestions to improve this speed. You don't need task and a cluster to do very simple async I/O there to make asynchronous requests to the web and do that on your laptop, or make it faster. Before plotting, try to assess the number of points you have, and if you have X amount that you're going to determine, always data shape it. Don't do the basic plotting. You're doing the basic plotting there, so that's why your computer froze. So just use data shape and rust right. And then you have a static plot even with
At some point we were doing, we had a data shape of Falcon, right?
Yeah, but we changed to points. It's possible to data shade the.
It is. It's going to be different because we don't have exactly the same information. But what I would do in each month, if my return has X amount of points, data shade it. If not, do the normal point.
Yeah.
Last but not least, there is some for fake errors. Some may be because they're hitting the same stuff too much. Others may be because the big bug in the my library, so found the data when it shouldn't. We need to sort those out. If you're hitting a server too much, there is another library as well, retry, that takes a step back, 2 seconds later tries again. If it's into plot, take another step back. That's longer and longer until the server starts responding again. We can fix that.
Oh, so I have a question. Sorry. Yeah, I was like, what was happening here was I tried to implement this in task. Right? So the lots of time that was consumed in this was, so we have a server, and the server has data sets. So one server has so many data sets. So first of all, we loop through servers, right? And then second, we loop through data sets
On the same server.
Yeah, on the same server.
Yeah,
Yeah. So what? So the problem with DOS is what I parallelized was first we searched different servers parallelly. It was okay. I got all the results. But then I'm hitting the same servers parallelly. Then it's always giving error and error, and so it's like.
Would you like if all of us poke you at the same time? That's what you're doing with this server. It doesn't like that. That's why you have to do something like the try and see and wait for it. The last thing is, if you break this down very factory in very small functions, you can use LRU cache on those functions. So if the query is the same, it doesn't query the server, just return whatever it already has. This improves the speed a lot when you're using widgets like that. Like for some reason, I reduce the amount of time and query for the same variable, it's going to be way, way faster for the next request. That's going to be on cache. Sorry, I know it's not a question, but I was kind of excited. Really good. I'd love to see this develop. Any other questions? Any more questions?